Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. The website of the program is at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today. Exam MLC, Fall 2016, problem number 6 in multiple choice section. For a special fully discrete whole life policy on a 48-year-old, you are given that the policy pays $5,000 if the insured dies before his median curtailed future lifetime at issue, and $10,000 if he dies after his median curtailed future lifetime at issue. Mortality follows the illustrative life table. Interest rate is 6%, which is the same interest rate as the one used in the illustrative life table. Calculate the actuarial present value of benefits for this policy. So the median curtailed future lifetime at issue in this case means the median of a discrete random variable K48 based on the data in the illustrative life table, and that means that this median is an integer, let's call it m, such that the probability that K48 is less than m is less than or equal to 1/2, and the probability that K48 is more than m is less than or equal to 1/2. Now this is a discrete probability distribution, so there are positive probability weights assigned to some specific integer values in this case, and that's why the median definition is so strange. It says no more than half probability to the left and no more than half probability to the right, but there may be a positive probability in the middle. That's the point. So the probability that K48 is less than m, well, that's actually the same as probability that T48 is less than m, the continuous lifespan, which is 1 minus the probability that T48 is greater than or equal to m, which is 1 minus MP48, which is 1 minus L48 plus m divided by L48. And the probability that K48 is greater than m is the probability that K48 is greater than or equal to m plus 1, which is m plus 1 P48, so it's L48 plus m plus 1 over L48. So finding the median is actually equivalent to finding an integer m such that 1 minus L48 plus m over L48 is less than or equal to 1/2. That's equivalent to saying that L48 plus m over L48 is greater than or equal to 1/2, and at the same time L48 plus m plus 1 over L48 is less than or equal to 1/2. So basically we switch from the ratio of this population size at a given age to the population at 48 being more than 1/2 to less than 1/2. We're looking for that magic point where that happens. So in the illustrative life table, we first need to find L48 first. And that's 9,045,679, and half of that number is 4,522,839.50. And then we see that L78, which is in the table 4,530,360, is more than 4,522,839.50, while L79 is less than that number. So we have the L48 plus 30 over L48 is greater than 1/2, while L48 plus 30 plus 1 over L48 is less than 1/2. So that means that m is 30, the median we're looking for. Therefore, this life insurance policy pays $5,000 at the end of the year of death, because it's a discrete policy, if the insured dies within the first 30 years, and it pays $10,000 also at the end of the year of death if the insured dies later on. And the actuarial present value, or expected present value of the death benefit, is therefore, it's $5,000 of 30-year term insurance plus $10,000 deferred by 30 years whole life. So it starts at 78. Well, if we add 5,000 of that term insurance plus 5,000 from the second one, then that's altogether 5,000 A48, and A48 is given in the table as 0.22892. Or it's actually 1,000 times A48, but from that we can figure out that A48 is 0.22892. And then the other half of that deferred insurance is the other 5,000 times 30 E48 times A78. And 30 E48, the pure endowment factor for 30 years, is not in the table, but 20 E48 and 10 E68 are, and 30 E48 is a product of these two. So we look them up, we plug them in, multiply them by A78, which we get from the table as 0.63656. Plug in all the numbers, we get approximately 1042.14. That's answer A. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. It's reproduced with permission, but the solution is mine, and all rights to it are reserved. And any use of this other than watching it on this site requires written permission from the copyright owner. Good luck in your studies and good luck on the test.